In this lesson, I will be teaching you how to predict the size of an ionic radius as it changes from its atomic radius. Now, as you guys already know from our course periodic table, we have the oxidation states listed for you. These are the charges that these elements love to become when they become ions. For instance, beryllium 2-2, or for a more advanced course, 1s2, 2s2, loses 2 electrons to have the same electron configuration as helium. The reason why they lose 2 is to become as stable as helium. It's a very stable electron configuration. It fills its energy shell. Now, of course, fluorine likes to gain 1. So the reason that these atoms, okay, become ions is to become stable. Fluorine is 2-7, it has 9 electrons, and when it gains 1 more electron, it has the same configuration as neon, another stable noble gas family. They have filled principal energy levels or very filled orbitals, okay, and it makes them very stable. The octet rule is something that you may use in your course and something I will begin to start using. Once you achieve this octet here, this 8, you have tremendous stability in that energy level. Okay, and again, these are the most stable, this family right here. Now, where I'm after today is how does the radius of an atom change when it goes from, let's say, boron to boron +3 or fluorine to fluorine -1. So let's look at that. So I picked 2 different elements that have 2 different types of reactivity. I picked boron, who likes to become +3 that we saw on the periodic table, and we saw fluorine likes to become -1 on the periodic table. These are the 2 different types of reactivity that we have. Now you should know at this point in time, for boron to become boron +3, for it to become +3, that had to be done by the loss of 3 electrons, and we've looked at this already in this course. Now, how do we know that? Well, if you look in the periodic table and you look at that boron has this information given to us, okay, and now of course the top number is the atomic mass number. It tells us the mass of the nucleons, the things in the nucleus, and then we have the what? The atomic number. Now the atomic number tells me the number of protons, but it also tells me the number of electrons when you're dealing with an atom. And as I tell my students, atoms, you say atom, I say neutral. Atom, neutral. Atom, neutral. Now, if it's neutral, it's because the protons, and there's 5 of them, so +5 in the nucleus, we call that a nuclear charge. -5 has to be outside the nucleus, which of course is done by the electrons. 5 of them is needed to give you an overall charge of 0, which is neutral. So in order for boron to become boron +3, if it's still boron, it must mean the elemental symbol is not changing, which means the number of protons cannot change, okay, as we've already learned. So it's because we lost 3 electrons. So boron has 5 electrons when it's an atom, neutral, and it has what? Well, 2 electrons remaining when it is a ion. Now, the type of ion is called a cation, and it's a positive ion. And anything that loses electrons, any elements that are big enough that lose electrons to become stable, become positively charged. Okay? Now, oppositely, I think is a word, if we have fluorine and we look and we see atomic number 9, that tells me that I've got +9 in the nucleus due to 9 protons, and I'm going to need 9 electrons for this to be 0 charge because it's an atom, neutral. Atom, neutral. So my friends in chemistry, this of course has 9 electrons. Atoms always have the same number of electrons as their protons in the nucleus to become neutral. Now to become -1, because it's still F, and as I said before, elements are identified by their number of protons. If it's still F, it's still 9 protons for the fluorine atom, neutral, okay, and the ion, which is not neutral. It's some charge. In this case, it's -1, and we call it an anion because it gained an electron. It's negative. All right, so in this case, there's a gain of electrons. In this case, we gained 1 electron. And that's what nonmetals tend to do. They're so small, they attract their own electrons. They have the ability to gain electrons to become as stable as a noble gas counterpart. In any case, this started with 9 electrons when it was an atom neutral, and when it became -1, it gained an electron, and now it has 1 more. Okay? Now, that's not what this lesson's about, but I want to make sure we still understand the basics. Now, what happened to the size? Well, let's start with our boron here. It starts out as an atom. Let's write the size. Okay, so let's write I guess an appropriate size for boron. And when it becomes +3, you notice I'm drawing a smaller radius. The radius, the atomic radius, gets smaller when I become positive ion. Now why? Well, it's because, well, if I'm losing 3 electrons, I still have 5 protons, which I know are positive, right? +5 overall. 2 electrons gives me a -2 overall. You can see that the protons outnumber the electrons. So the 5 protons that are in here, okay, overwhelm the 2 electrons, right? I guess I'll draw 5 because I can. So the 5 protons outnumber the 2 electrons, and these electrons feel, okay, this +5 now more than they did before because they're being outnumbered. And so these are pulled in closer and the radius gets smaller. When it was an atom neutral and you had the same number of electrons as protons, they weren't pulled in as much. But when you lose electrons, the remaining electrons feel the nucleus more and they get pulled in. All right. Now if we look at fluorine, okay, it starts out as a pretty small element, a non-metal, and when it becomes negative, it gets bigger. Well, how did that happen? Well, in this case, by gaining the electrons now outnumber the protons. And if you have more electrons than protons, what happens is that the electrons can pull away, and I'll just draw 9 protons, 9 plus in here, and the nucleus. And if I gain an electron, now I have 9, if I'll draw them, these 9 electrons, because they outnumber, up to be 10 now, right? I can do this. 10 electrons, these 10 electrons outnumber the these 9 protons, and they pull away. When it was an atom neutral, you had equal number, but when you gain an electron, as in the case of nonmetals, you have more electrons than protons, and they outnumber the 9 protons, and each electron feels a nucleus less by gaining 1 more electron. It's -11 out here, -10 out here, -9, +9, so this bigger number pulls away. Now, if you don't like that explanation, one way to easily remember this is this. When we go back to the boron, when it loses electrons like most metals do, okay, although boron is a semi-metal or a metalloid, but it has characteristics metallically like most metals because it loses electrons here. In any case, you can say this: boron's atomic radius is bigger than its ionic radius. I'll write this in. Boron's atomic radius is bigger than its ionic radius. And that's some kind of wording you have to get used to. Whereas fluorine, because it gains electrons, its atomic radius is smaller than its ionic radius. Be careful with those types of questions. When someone asks you which of the following choices is the atomic radius bigger than its ionic radius, that means when it was an atom, it's bigger than its ion, which means when it gets smaller, okay, we're talking about something losing electrons. Now you may say, Mr. Grodsky, how do I keep this straight? Getting bigger, getting smaller, positive, negative. The easiest way is to do this. If I lose weight, do I get bigger or smaller? Here's Mr. Grodsky. And if I somehow lose weight, okay, I would get smaller, Mr. Grodsky. Okay, not sure if I can draw that correctly, but boron gets smaller because it's losing electrons. Or if you lose weight, you get smaller. So anytime you lose electrons, it's like losing weight, and your ionic radius is smaller than your atomic radius. Or the radius of the ion is smaller than the atom, or you get smaller when you lose weight. The nonmetal way, when you gain electrons in this reactivity, what? You gain electrons, you gain weight, you get bigger. Your ionic radius is bigger than your atomic radius. Okay? So that's how it works. If you don't like this way that I'm explaining who's outnumbering who, see who's gaining weight. That's the one who's getting bigger, the ionic radius. Who is losing weight? And of course the weight is the electrons. Okay? Hope that helped.